Welcome to the math story of Math 1, Unit 6, Exponential Functions. I'm Karen McPherson, and I'll be your guide on this journey. Let's begin by looking at the overview of this unit. What do you notice, and what do you wonder? You may have noticed that the unit begins with exponent rules. This is intentional, as students will need to be able to interpret negative and fractional exponents to make sense of exponential functions, where the input value does not need to be a positive integer. Next, students explore and define exponential growth and decay patterns. Notice that the checkpoint lesson splits the section on exponential decay. This allows time for additional instruction or practice before students apply their understanding of exponential functions by comparing and interpreting their parameters. Lastly, students explore percent change and how it relates to exponential patterns. The remainder of the unit includes the third of the 4 modeling lessons in Math 1, the Putting It All Together lesson, and test post-test activities. Before diving into the exponential functions, let's take a quick look at the development of the exponent rules. In 8th grade, students generalized exponent rules for powers of 10. They extended the generalizations to expressions with other numerical bases. In Math 1, students explore expressions when the base factor is a variable. The rules are developed by students applying the definition of an exponent to expand the expressions. Students make use of repeated reasoning to discover the rules. This is similar to how students explored the rules in 8th grade. Being able to explain why each rule works helps to develop students' flexibility in reasoning with more complex expressions. To build fluency, students will continue to apply these rules in practice problems throughout the unit. The next section begins the study of exponential functions and focuses on exploring exponential growth patterns. Before starting on exponential functions, a quick reminder that students are familiar with linear functions from previous units in this course and from work in 8th grade. They have created and used multiple representations, such as tables, graphs, and equations. They are able to identify and describe key features of a linear function, such as an initial value, the y-intercept, and a constant rate of change, slope. These features will be compared to a new pattern that students will come to understand as exponential. The first activity, a genie in a bottle, presents a situation where a genie proposes 2 options. Purse A offers $1,000 and adds $200 each day. Purse B offers only a penny and the amount doubles each day. Students investigate the amount of money in each purse over time. Next, students examine the graphs of both options and interpret different points. They see that the pattern, which grows by repeatedly doubling, starts off slowly, but eventually overtakes the other pattern. After the initial exploration, students take a closer look at the way the functions change. In this situation, students are looking at 2 plans for expansion of a chain of stores. Plan A opens 20 new stores each year, and Plan B doubles the number of stores each year. Students are prompted to calculate the difference from previous year for each plan and the factor from previous year for Plan B. This builds towards defining common difference as current subtract previous and common factor as current divided by previous. It will be important for students to know how to find these values, especially when they are not as obvious as adding 20 or multiplying by 2. Lastly, students focus on expressions that represent a situation with a common difference and those that represent situations with a common factor. This provides the opportunity for students to notice the structure in the expressions, in particular, the different ways repeated addition and repeated multiplication can be represented. Now that students have been introduced to this new pattern of change, they turn their attention to expressing the relationship with an equation. In this activity, students consider how cells growing by splitting. They write expressions to calculate the number of cells over time, which leads them to build expressions of the form a times b to the x power. The context for this activity, cells taken from Henrietta Lacks for diagnosis and treatment that are still used today for research, will be elaborated on later in the unit. Students use the Connecting Representations Organizer, or CRO, to analyze the different representations. The graph, table, symbols, and words make connections between the representations and the key features, such as an initial value, y-intercept, and rate of change. This next section focuses on exponential decay. Students have explored quantities that increase by the same factor. Up to this point, that factor has always been greater than 1. In this section, students will look at situations where the factor is between 0 and 1. Two essential understandings that are addressed in this first activity: what's left. Students may naturally think of decrease as subtraction. In this case, 1/4 of 100 is the amount Diego spent, and so subtracting that amount from 100 gives the amount remaining. By using the distributive property, it can be shown that multiplying 100 by 3/4 will also give the amount remaining. It is important to emphasize multiplication because exponential situations involve quantities changing by a common factor. It is also important to emphasize that the factor is the portion remaining, even though the portion that is being used is what's often given. The situation presented in this task is a car that is depreciating in value. Students apply their understanding from the previous task and identify that multiplying by 2/3 will express the value of the car. Once again, students look for and express repeated reasoning to write an exponential expression for the value of the car as a function of time. In previous lessons, students have examined the connections between different representations of an exponential function. In this lesson, students continue to examine situations characterized by exponential decay, but the emphasis here is on comparing exponential functions represented in different ways. In this situation, students are comparing the value of two cell phones, one represented by a graph and the other a table. Students determine which was most expensive when first released by identifying and interpreting the initial value. Students also determine the decay factor and use it to describe how the value changes each year. This goes back to an earlier activity where students learned to find the common factor by dividing the current value by the previous value. In this next activity, students compare the value of two computers over time. In this situation, they're given a graph and a rule. Students are provided the opportunity to revisit concepts from the earlier unit on functions and apply it to exponential functions. This includes function notation, domain and range, and average rate of change. So far in this unit, exponential growth factors have been represented by whole numbers, such as 2 for doubling and 3 for tripling. Exponential decay factors have been represented by fractions such as 2/3 and 1/2. In this section, students begin to reason with and make sense of factors that represent percent change. Building on work in 7th grade, students examined different strategies for expressing a percent increase as a single factor. One strategy is to add percentages first and then write the percent into decimal form. A second strategy is to rewrite the percent change into decimal form and add to 1. For a percent decrease, you can begin by subtracting the percent decrease from 100. This gives the percent remaining. Then write the percent remaining into decimal form. Or the percent decrease can be written into decimal form and subtracted from 1. While either may be used by students, these lessons emphasize the first strategy to help students develop an understanding of the growth and decay factors in contextual situations. This will be important for when students need to interpret the factors. This activity returns to the story of Henrietta Lacks. Students explore the situation if Miss Lacks's family were compensated for their use of their ancestors' cells. Applying the concept of compound interest, students write an exponential function and use the function to predict the value of the account now. The next situation models income from movie ticket sales since the movie's release. This provides students the opportunity to reason with percent decrease. In this card sort, students take turns selecting a card, identifying if the factor represents growth or decay, and interpreting what the factor means as a growth or decay rate. Lastly, students revisit modeling data with a function. Either through an optional experiment or by video, students collect data on the bounce number and height of the ball. They use Desmos to graph the data and consider the shape and relationship to determine if the linear or exponential function would best model the data. Students generate a regression equation and then interpret the parameters within context. A technology tip handout is provided. That brings us to the end of the core lessons in Unit 6, Exponential Functions. Let's take a quick look at the public records that will help students track their learning throughout the unit. First, there's exponential rules. Next, exponential growth shows all the different representations, and the same with exponential decay. And lastly, there's percent change. This concludes the math story of Unit 6, Exponential Functions. Thank you for all you do to support our students.